Hello and welcome. In this video, we're going to be discussing how to solve a system of equations using elimination. So before we begin with this problem, I just want to show you something that is going to be helpful to us. So imagine I start with these two equations, 5 plus 2 equals 7, and 3 minus 2 equals 1. So what I want you to notice is what happens when I add these two equations together. So if I just add going straight down, 5 plus 3 is 8. Then I have 2 plus negative 2 is 0. So I end up with 8 plus 0. And on the other side I have 7 plus 1 is 8. So a couple things I want you to observe. Number one is that the two sides are still equal to each other. And the second thing is that the 2's kind of eliminated themselves. So we're going to kind of be using the same sort of idea with this elimination technique. So what I want to do is basically set these equations up so that I can either eliminate the x's or the y's. So in this particular example, I'm going to focus on eliminating the x's. Okay? So the reason I'm doing that here is that one of my x's is negative, one of my x's is positive, so it's already set up that they're opposites of each other. What I need to come up with is a least common multiple between negative 3 and 5, or between 3 and 5. That's going to be my first step. So I've written out our first step. We want to find a least common multiple between 3 and 5. So I think 15 is going to be that least common multiple. The next step then is I want to basically multiply the top equation and the bottom equation by whatever number it takes for me to get to either positive 15 or negative 15. So that's going to be my second step. Okay, so I've just written out both of our equations, and then I've written out our steps. So what we're trying to do is we're trying to make this guy into a negative 15x, and we're trying to make this guy into a positive 15x using multiplication. So to do that, I'm going to take the first equation and I'm going to multiply both sides by 5, because 5 times negative 3 would give me negative 15. The second equation, I'm going to multiply both sides there by 3, because 3 times 5 would give me positive 15. So if we do that, our first equation, if we distribute through, I would have 5 times negative 3x is negative 15x, plus 5 times 2y is 10y, and whatever I multiply one side of my equation by, I have to do the other side, so 5 times 17 is 85. The bottom equation, 3 times 5x is 15x, 3 times 7y is 21y, and then 3 times negative 18 is negative 54. Okay, that's my second step. My third step then is, you'll notice my x's are set up to be eliminated. So my third step is to add the two equations together. Okay, so I've just written our third step, so we're going to add our two equations together. I've recopied our two equations, so here we go. So if we add our two equations together, well, first I've got negative 15x plus 15x. Those guys are going to become 0. Then I've got 10y plus 21y. That's 31y when I combine those. On the other side, I've got 85 plus negative 54 is 31. And now the next step, step 4, is we want to solve the equation that's left. And notice it only has one variable in it. Okay, so I've written out step 4, solve the equation, and then I've rewritten our equation. So to solve that equation, we're just going to divide both sides by 31. And that gives us y equals 1 as part of our solution. So again, when we're solving this system, we want to find not only the y-coordinate, but also the x-coordinate. So our last step in the process is to solve for x. Okay, if we had solved the first one for x instead of y, we'd be wanting to find the y coordinate. So here we want to find x because that's the one that's missing. So I've recopied our original two equations. Now that I know what value y has, I can plug that into either one of these two equations, and it should give me the same x value. So what I'm looking for is which equation looks more manageable for me to do. Well, they both look about the same. Since this one has a negative, I'm going to actually choose to plug my y value in to this guy. So when we do that, we get 5x plus 7 times 1 equals negative 18, which gives us 5x plus 7 equals negative 18. Subtract 7 from both sides. That gives us 5x equals negative 25. Divide both sides by 5. Gives us x equals negative 5. So that's the second part of my solution. So I've got my y value from back here. I've got my x value. So that means my solution, I want to write as an ordered pair. The x coordinate is negative 5. The y coordinate is 1. Okay, here's another one for you to try. Pause the video and then restart after you've given it a shot. Okay, so in this particular example, in terms of eliminating either the x's or the y's, I think it's probably going to be about the same amount of work. So since we eliminated the x's in the last example, let's actually do the y's this time, just to show you that it's a very similar process. So what I want to find is a multiple that's common to these two guys. So I think there the least common multiple would be 20, which means I'm going to want to multiply the first equation by 5, because 4 times 5 is 20. I'm going to take the second equation and multiply both sides by 4, because 4 times negative 5 is negative 20. So we're going to multiply the top equation by 5, the bottom equation by 4, and if we distribute through, the top equation becomes 5 times 5x is 25x, 5 times 4y is 20y, 5 times 15 is 75. Remember, we've got to distribute to both sides of the equation. On the bottom, 4 times negative 6 is negative 6x is negative 24x. 4 times negative 5y is minus 20y. 4 times negative 19 is negative 76. And now I want to add my two equations together. Notice the y's are in prime position here to be eliminated. So if I combine my x's, 25x and negative 24x is 1x, or just x. 20y minus 20y, those become 0. And then on the other side, 75 and negative 76 is negative 1. So in this case, we got really lucky because we don't really have to do any solving. We know that the x-coordinate where these two systems or these two lines meet is at negative 1. Now I got to find the y value. So what I want to do is pick one of my two original equations, either this one or this one, plug the x value in, and solve for y. So again, it doesn't really matter which one I pick. I would get the same solution either way. I'm going to pick the first one. So here we go. We've got 5 times negative 1 plus 4y equals 15. 5 times negative 1 is negative 5 plus 4y equals 15. Add 5 to both sides. Gives us 4y equals 20. Divide by 4. Gives us y equals 5. So now our solution is x is negative 1 and y is 5.